We picture the modern smart city as an endless, flawless stream of information, traffic routing itself, power grids balancing, millions of devices communicating in real time. But underneath that efficiency lies a fragile foundation. Most of these automated systems depend entirely on a continuous internet connection to function. If the Wi-Fi drops, the control drops. This chart models projected network resilience for 2025, and it exposes the risk. The pulsing line represents network uptime, but these sudden drops track 68 forecasted major internet outages, culminating in nearly 900 hours of nationwide disruption. Those 38 days of downtime carry immense weight. That red zone translates directly to $1.62 billion in economic losses as commercial and industrial operations grind to a halt. The digital infrastructure running our daily lives is resting on a cord that can be surprisingly easy to cut. When the network fails, the consequences move quickly from digital dashboards to physical reality. Think of continuous operation facilities, research labs, hospitals, and heavy industrial plants. The majority of these environments still manage their critical hardware through internet-based controls, or they rely on slow manual intervention. In densely populated metropolitan areas, the baseline for physical safety is already stressed. For example, 80% of commercial buildings in cities like Karachi lack basic integrated fire safety infrastructure. In settings without integrated safety, a brief connectivity drop or a momentary power failure prevents automated emergency systems from triggering. A minor technical glitch quickly compounds into a severe, uncontainable hazard. A city cannot effectively protect its citizens or its economy if its critical infrastructure goes dark the moment the internet connection fails. Organizations need a system built for unbroken resilience. That is the architecture behind NighebaaN, an automation platform developed by Zinovaa. At the core is an IoT-powered industrial control unit engineered specifically to eliminate the single point of failure that plagues standard cloud-based hardware. The system guarantees continuous operation through a three-tiered architecture. Tier 1, a cloud-connected mobile app for remote management. Tier 2, if networks crash, an independent cellular fallback executes emergency triggers. Tier 3, the ultimate failsafe, providing fully offline, localized access via a desktop application. Because of these overlapping layers, facility managers maintain complete command over their critical electronics and machinery, even during a total communications blackout. This level of reliability is necessary for high-stakes environments. The system is built for large-scale deployment, targeting IT parks, university campuses, and high-security sites that require thousands of control points. It acts as a bridge, upgrading legacy, manual machinery into a responsive, intelligent grid, without requiring organizations to replace their existing equipment. The core architecture is fully operational and is already supported by strategic market partnerships, including an active collaboration with Firebox, expanding into South Africa. Organizations are seeking these solutions to protect their assets, driving the industrial control systems market toward a projected $328 billion. Offline first control is no longer an optional safety feature. It is a strict prerequisite for any industry attempting to automate at scale. Beyond operational efficiency, the real stakes here are entirely human. When industrial machinery or building infrastructure fails, faster emergency response times directly reduce the severity of injuries and prevent fatalities. By ensuring immediate, fail-proof SOS alerts go out regardless of internet status, the system secures urgent medical assistance and creates a secure environment for the people working inside these facilities. This hyper-localized approach to safety directly supports the United Nations mandate for sustainable development, specifically the goal of making our cities inclusive, safe, and resilient. The technology extends outward into broader civic applications, enabling reliable smart surveillance networks, accurate crime mapping, and highly durable disaster preparedness systems. Digital inclusion is realized when public safety infrastructure protects the most vulnerable citizens during worst-case scenarios, ensuring critical protections remain active even in a total blackout. We used to define a smart city by how much data it could rapidly push to the cloud. Today, a truly smart city is defined by its localized, unshakable resilience. NighebaaN delivers the invisible, offline-first foundation needed to build communities that can genuinely protect their people. Real innovation doesn't go dark when the connection drops.